Welcome to today's session on contractor reliability. As industrial facilities increasingly rely on third-party experts for maintenance, a critical question emerges. Who truly owns the quality of work when maintenance is outsourced? Today, we will explore the essential framework of scope, competence, interfaces, quality, and handback to ensure that external work doesn't become internal risk. Let's start with a scenario many of us have faced: the composite plant moment. A contractor reports 100% completion. The flange passes handback, but it leaks immediately at startup. We often find out too late that a gasket was substituted, records were incomplete, or the night shift used a different standard. This highlights the consequential point of return to service where contract boundaries often obscure technical ownership. We need to ask, who had the authority to accept, and what evidence was missing that should have stopped that closure? Why does this matter? From a seasoned practitioner's view, we must recognize that while work can be contracted, asset risk cannot be outsourced. Price is never a substitute for performance. Low hourly rates often hide the costs of rework and defects. We must realize that interfaces create risk. Competence is task-specific rather than just a company certificate, and technical acceptance must be based on hard evidence before equipment is ever closed. By the end of this session, you'll be equipped with 6 key outcomes. From choosing the right contracting models and writing outcome-based scopes to pre-qualifying competence, integrating contractors into plant systems, controlling quality hold points, and using performance measures that value the entire life cycle of the asset. Our first step is to see the risk clearly. We need to identify the system conditions that transform ordinary maintenance tasks into significant enterprise risks. To solve the problem, we must speak the same language. We'll define a contracting strategy as a risk-based decision and distinguish between owner responsibility for the asset and contractor responsibility for execution. Crucially, we'll look at hold points and handback, the controlled transfer of evidence that proves an asset is ready for service. The cost of a failure is always larger than a maintenance invoice. When we talk about reliability risk, we're talking about process safety during invasive work, future reliability through the prevention of latent failures, schedule certainty by avoiding rework, and the retention of the owner's capability to actually oversee the work. Failure in the field is rarely a single bad act. It's the end of a chain. It starts with the wrong sourcing model, moves through ambiguous scopes and weak mobilization, drifts at the interfaces of shift handovers, and concludes with an evidence-free handback. To fix the field event, we have to fix the technical controls upstream. Warning signs usually appear long before an incident. Are you seeing scope ambiguity discovered during execution? Is competence being substituted after mobilization? Are crews waiting for permits? These are quality escapes and warranty amnesia in action. If these signs are present, the system is drifting toward failure. To assess your current state, ask these 8 questions. Don't answer with your intentions, but with evidence. Can you prove your workers are verified for specific tasks? Are your hold points positioned before attributes are hidden? If you can't answer yes with data, your reliability system may only exist on paper. Now that we see the risk, we move to section 2, building the operating model. This is about creating a disciplined system with explicit decisions and verifiable evidence. 5 principles keep this model practical. We must retain intelligent ownership, enough knowledge to challenge the contractor. We must scope outcomes, not just labor. We must verify the actual people on site, integrate them into one single work system, and always accept work based on technical evidence. Introducing the OWN 6 Contractor Reliability Model. It's a 6-step journey, from strategizing and specifying to qualifying, mobilizing, executing, and finally accepting and learning. This model ensures that the contract clarifies accountability without creating a dangerous distance from the asset. Step 1 is strategize. Before a tool is lifted, the asset owner and procurement must assess the risk profile, define what technical capability must be kept in-house, and select a commercial model that incentivizes the right behavior. Next, we specify. This is where maintenance and engineering define the technical scope. It's not enough to say fix the pump. We must clarify boundaries, exclusions, and most importantly, the specific criteria for acceptance and the records required for handback. The third step is qualify. We aren't just looking at the company's past performance. We are verifying the named skills and supervisors assigned to our specific job. We must control for bait and switch substitutions to ensure the competence we paid for is what we get. Mobilize is the bridge to the field. It requires a joint work pack walk down to ensure everyone understands the site-specific risks and has the right tools and materials. This phase should culminate in a readiness certificate before work starts. During execute and control, we manage the interfaces. Contractors must be part of the site's permit and SIMP system. Owners must supervise and release defined quality hold points, ensuring that any deviations are caught and managed through a formal nonconformance process. Finally, we accept and learn. This is more than a signature. It's a technical review of as-left records and functional verification. We close out warranty items and score the performance to inform the next sourcing cycle, ensuring the organization actually learns from the work. To prevent convenience from becoming policy, we need clear decision rules. For example, if schedule pressure conflicts with acceptance, the rule must be to protect the standard and escalate the impact rather than transferring unverified risk to the startup team. The model is the theory. Now we must make it executable. Section 3 focuses on translating these concepts into daily field workflows and management rhythms. Reliability often fails in the gaps between functions. We need to name one accountable owner for each role, from the asset owner who retains the risk to the contract owner who manages the commercial interface, and the operations team who controls the process state. Standard work turns intent into repetition. By following this controlled sequence from strategizing to sustaining, we ensure that every job, regardless of the contractor, follows the same rigorous path to reliability. Critical controls must be specific and observable. A procedure isn't a control until it involves a defined action and a verification method, like a named competence register or a joint readiness walkdown. These are the tangible breaks and checkpoints in your system. Data should only be captured if it changes a decision. We need to track the scope boundaries, the competence of named individuals, readiness status, and the evidence of quality. This data connects the commercial contract to the physical condition of the asset. We must use measures that trigger action, not just admiration. Pair leading indicators like mobilization readiness and hold point compliance with lagging outcomes like rework hours and post-work defects. This gives a true picture of the total delivered cost, which is far more than just the invoice rate. Culture becomes durable through management cadence. This isn't about more meetings, it's about the right rhythm. Shifts focus on immediate exceptions, while quarterly reviews verify that standards are actually being used in the field. Technology should reinforce our discipline. By integrating contractors into the owner's CMMS, permit systems, and quality management tools, we create a single source of truth for the asset's history and current state. In Section 4, we look at how to apply, verify, and sustain this method. We want to scale only after we have evidence that the system works in a real-world environment. Recall our composite case of the leaking flange. Before the intervention, we had ambiguous scopes, unverified substitutions, and inspections happening after installation. At the decision point, the owner has to decide how to protect the startup without micromanaging the contractor's every move. The intervention applies the 6-phase framework. We clarify the technical authority, specify torque and material requirements, verify the specific technicians, and mandate inspections before installation. We are changing the system, not just reacting to a leak. Success is visible when each joint has a traceable record and substitutions are impossible without a formal process. The key takeaway here is that retained ownership isn't micromanagement. It's the technical act of ensuring a safe return service. In our training application, consider this tabletop exercise. A contractor mobilizes with different technicians and tools than promised. Which changes are acceptable? How do you verify their competence on the fly? These are the real-world decisions that test the strength of your reliability model. Avoid common implementation traps. Don't select based on labor rate alone. Look at the total delivered cost. Don't assume company qualifications equal individual worker competence. And most importantly, never inspect after closure. Always place hold points while attributes are still visible. Here is your 90-day roadmap. Start by baselining your risk and selecting one pilot contract. In the second month, implement the new scope and hold point workflows. By day 90, you'll have the evidence of total delivered cost and handback quality needed to scale the standard across the plant. When communicating with management, build a credible business case. Highlight that total delivered cost includes the price of waiting, rework, and potential post-startup loss. The value of this system lies in reduced risk and stronger lifecycle quality, not just a lower invoice. To maintain the system, use this 12-point field audit. Score only what you can actually observe or trace. If sourcing decisions don't document retained capability, or if tools aren't verified before mobilization, you have identified a gap that needs closing. To synthesize what we've learned, outsource the execution where it adds value, but always retain intelligent ownership of the risk. Commit to 3 rules: no contract without ownership, no mobilization without competence, and no handback without evidence. For those looking to dive deeper, we provided a list of regulations, standards, and case studies, including OSHA and ISO guidelines, that reinforce the principles of contractor management and process safety. We also want to acknowledge the sources of the industrial photography used throughout this presentation, which help visualize these complex environments. As we close, I'll leave you with one final thought. The contractor completes the work, but the owner accepts the risk. Who in your organization truly owns the as-left condition when that contract ends? Make the risk visible, make the standard executable, and always verify the result. Thank you.